Okay, welcome everyone to this week's compiler architecture meeting. So today we've got 3 topics. I think they're all somewhat related though. They've come out of some discussions that have been occurring recently in some of the OMR issues. I think the first one that we have on the agenda is probably sort of the umbrella topic that covers the other 2. Leonardo Bandarelli has graciously agreed to moderate the discussion on the first point, so on choosing developer guidelines for IL opcodes, deciding when to use IL opcodes versus symbols. So it's a fairly important topic for us to come to some kind of an agreement on. So I'll turn it over to Leonardo to...
Sure. Thank you, Daryl. I'm hoping most people here are familiar already with the topic. I won't try to summarize everything because there's been a lot of discussion going on, a lot of really good discussion, I think. But the gist of the issue is, what are our guidelines for whether a particular feature or functionality in the JIT compiler is represented as either an IL opcode or a non-helper function, a non-helper being some sort of function-like thing representing functionality that a code generator can simply know as an intrinsic how to generate code for, or just do something reasonable that will emulate the correct behavior. So I will turn then the discussion over to people to share their thoughts.
Is there a particular opcode that prompted this?
Yeah, well, that's actually the next discussion point.
Leading question that you asked.
ipopcount and lpopcount opcodes. I believe, yeah, the question was whether we want to remove them or keep them, and originally it was proposed by Nigel, who is not here at the moment. And there was another one that was for ipopcnt, that's right.
Mm-hmm. So there's been a fair bit of discussion in that particular issue. I guess we can kind of repeat it here in sort of a replay fashion to kind of go through some of the issues. But I think what it maybe is getting down to is what does it mean to be an IL opcode, and under what conditions should, if you're thinking about introducing some new functionality, and let's say that functionality is very similar to a what we traditionally think of as a compiler intrinsic, do those warrant a new opcode, or should we be introducing more of a notion of a compiler intrinsic that we use?
I think we should establish the fact that there really is no difference between the two, except the only one that I could think of is that calls always have to be anchored, and other things can appear as children. And what that means is that things that appear as children basically have the property of implicit code motion. When the optimizer does things to the code, these things can move around, whereas calls are always anchored and they don't move. But I've tried to think of examples that contradict this, and I couldn't really come up with anything. So to me, that's the main distinction between the two. So if anybody can think of anything else in that regard or any differences,
I think the aliasing of the call would be.
I very much agree that these 2 representations are fundamentally equivalent in that anything we wanted to do with the one representation, we could do with the other if we so chose, right? So this thing where calls are anchored is a peculiarity of our particular IL. But the fundamental thing is, you know, you sort of write down the information one way or you write it down another way, but you've written down the same thing. Although I do think that there are other peculiarities of calls that occur in our compiler and quite possibly in other compilers, given that calls are often opaque. You know, if you don't know specifically what something is, and all you know that is that it's a call, you're liable to get conservative around things. I think if we represent some of these cheap operations that are arithmetic-like as calls, it exempts them from a lot of extremely generic optimizations like dead trees, most likely.
There's a few ops that will get more conservative after checking if you're a call or not. That's a very valid point.
Like local common sub-expression elimination almost certainly does not comment them. Value numbering probably does not
Do we have a
recognize that they're
notion of
the
a
same.
side effect free call?
Side effect free.
We do have a pure call. But it's still anchored, and it still doesn't get to float around the way a child would.
Right.
And unless an optimization specifically opts into doing something special for them.
Right. They would need special handling.
Yeah. So by default, a call is a call is a call, whether it's marked as purely functional or not. There are select places where the optimizer chooses to do something special, but in general, it's a call.
I should say that the notion of pure call was introduced much later, therefore it gets somewhat of second-class treatment in the optimizer. As Andrew said, ops can opt in. Not everyone who can opt in does at this point, so it would require work.
Right. And it's additional work to do it, and it's
Doesn't that apply to any new functionality that you want to?
Oh, so if you added an opcode,
you'd still have
a lot
to
of
go
these
around.
things apply sort of transparently, right?
Yes, I mean, in some cases, you need to know the semantics of the new opcode that you added. Things like value propagation and simplifier certainly fall in that category. But there's a class of ops that don't even need to know what the operation does, as long as it returns an int, for example, and is expressed like any other arithmetic operation.
Right.
It can be pulled out of a loop, for example, and put into a 10. That's the classic example. It can be commented by local CSE. Doesn't need to know what it is, as long as it's not explicitly excluded in some way, and making it a call, certainly a non-pure call will exclude it.
So is that a matter of just teaching the optimizer to treat a certain class of calls like that, or is there some other?
Well, I mean, there's a fundamental.
You can't just allow them. They have to be treated differently because of this thing where they have to be anchored.
Okay, besides the
So you
anchor,
can't
I mean,
just apply the same code that you were applying to general, like, nice operations.
Yeah.
You'd have to special case them, do something different. You'd have to figure out exactly what that different thing is. Right, like, if Dead Trees wants to move it to the point where it's used, that doesn't mean the same thing now, right? It has to do a different thing because it has to, find where it's used and then anchor it before that, and that sort of thing.
So the act of moving it is itself different.
Right, or like if PRE or versioner wanted to hoist it, which I think right now they wouldn't. If you choose to make something a call, they're just going to leave it alone, right? But then maybe you don't version something or whatever. Right.
Why do we need to anchor pure calls?
All calls must be anchored.
Right, but is that just a point in time statement, or?
No, calls have SIMREFs. Calls are potential side effect points, even if they're marked as pure calls from an IL validation standpoint. If you're going to allow calls to start floating around, I think all bets are off, and the IL is going to be very hard to understand.
For a pure call, it may even be more of a code gen reason than an optimizer reason, right? The code gens, and there are people more well-versed in code gen evaluator capabilities than me here. If you have a call appearing suddenly in the middle of some other non-trivial opcode that you're evaluating, I don't think the code gen can just start evaluating a call in the middle of an instance off or in the middle of a check cost or some other complex operation that requires internal control flow and has some non-trivial handling in the code gen, right? There's a reason it's anchored. You do the call on its own, and when you get to something else, you're just evaluating that something else. The call has already been done and results in a register.
And at another meta level in the IL, calls are nodes that have symbol references. So while calls are a family that are treated together, there are some ops that care about, do you have a symbol reference or not, because that is the notion of a potential side effect, and that there's a class of things that can happen to non-SIMREF holding nodes, right? Even outside of saying, are you a call, just asking the question, do you have a SIMREF, can
Isn't that
lead to that.
a little incorrect, though? If I have a SIMREF and somebody assumes that I have a side effect, isn't that their problem?
It's
It
not
seems to me
necessarily
like
that you have a side effect, but
if you're
generally
using-
a SIMREF indicates that something is not referentially transparent. So loads have a side effect, but it matters where they happen.
Yeah.
Or sorry, they don't have a side effect, but it does matter where they happen.
Yeah.
The only exception to this rule that I know of is load adder, which is effectively a constant.
Yeah.
I think we should maybe set that in stone so that SIMREFs have these sorts of properties, and because if we're talking about such somebody choose an opcode versus an intrinsic, and we're saying all calls have all these other properties and baggage, that's going to affect.
Well, okay, so part of that I think is going to play in there's two things I think that are playing there, which is part of it is an issue we've discussed previously, which is specification of DIL, needing to have some well-defined semantics for DIL. And the second thing is, what it sounds like is we need something that might be similar to a call but not a call for intrinsics that have certain properties that our current call opcode does not have. So maybe one solution is to change the specification of a call opcode so that it now no longer needs to be anchored and deal with all the potential side effects of that, or have some other opcode we can use to represent this call to a non-helper or intrinsic.
Right, but I think the fundamental thing is if you are going to create an opcode, right, there are a whole set of properties that you have to declare on that opcode to express to the optimizer how it should participate in a variety of common optimizations and data flow patterns, right, and things like, do you have a SIMREF or not, and is like use or is like def, or these various other things that capture behavior that a number of optimizations query without caring about the opcode. These are properties of the opcode, right, that allow it to participate in these general optimizations in specific ways. Now, intrinsics inherently are going to have a family of different kinds of behavior. Some of them will behave like adds, some of them will behave like loads, some of them will behave like volatile loads, some of them will have cockamamie semantics that we can't even sit here and think about. So trying to say that we should have sort of a meta opcode that's going to allow us to encode those various things is basically saying we want to be able to write intrinsics that behave like opcodes. So I think that the trade-off is in, so like if you look at the design choice about the participation of the opcode, right? Like if you're choosing an opcode, you're saying, okay, this operation is sufficiently common that I care about it participating in optimization in certain ways, that it is a generic concept that applies broadly in a number of places because I'm going to force many optimizations to explicitly handle it. And then you're opting into all of that work. If you're going to go the intrinsic route, what you're encoding is an operation that has very precise, or at least in my mind, very precise semantics. You don't care to have to teach every optimization how to deal with it because you aren't opting into having an opcode with all of the opcode properties and all of the work that entails. But by making that cheaper choice, you are inherently giving up some performance for the simplicity of the implementation. You are opting to go, this isn't sufficiently generic that I need to do all that work, and so the optimizer has to have a point where it assumes a certain level of conservatism to give you the flexibility to express a family of different things under one opcode. And that's just kind of like that's how I see the trade-off in these two things.
That makes sense.
So what about current IL opcodes that literally float down to the codegen?
So some of them, so the merits of the choice that somebody made in implementing an opcode versus a call, well, it comes back to this debate of how common is it, how useful is it, and how much do we care about wringing the maximum amount of performance and utility out of it, right? So, for example, we had a debate that was around like pop count, right? Population count. Now, that opcode was introduced, I believe, in a very specific corner case, and it's not generally participating in what people are doing, and arguably probably is a corner case where we don't particularly care to have it fully participate in everything because it's a kind of niche operation. Well, then that might be an example of something that wasn't the right thing to make an opcode. But if you're going to have like an atomic compare and swap, for example, or an atomic exchange, which is kind of a fundamental language feature for a lot of different languages that handle concurrency, maybe that is something where having the optimizer aware of the semantics associated with it could lead to better performance. But that being said, there's limited things you can do with it. Therefore, the effort that you would put into turning it into an opcode may not pay off, right?
So my feeling is that whether the optimizer either can or is forced to know about the semantics of this operation is unrelated to the choice between intrinsic and opcode. Optimizations have to deal with a whole bunch of stuff that they don't recognize all the time, and they have generic ways of doing so for sort of regular unobjectionable code, and for things that should sort of count as unobjectionable code, like popcount. It seems to me like it's perfectly sensible to allow the generic stuff that doesn't care to apply to it. It's sort of like if you make it in because of the peculiarities of calls that I mentioned earlier. It's if you make it an opcode. Now, for some of the things that would apply transparently to normal stuff, it's not normal stuff, and you have to teach the optimizer things if you want it to apply. But it's sort of like similarly, there was a concern about support in the codegen, right? So like, if these things become opcodes, then the codegen has to support them. And then there was a countervailing, like, we shouldn't have these queries like it supports square root, whatever, right? And regardless of which representation we choose, we have this problem. If we're going to have the operation explicit in the IL in any representation, either every code generator has to be able to generate code for it, or we have to be able to tell when that's not the case and we should avoid generating it.
Either way, you need a query to decide whether to...
Right.
Well, or you need to force the code gens to implement it, right?
Right. What I'm saying is we shouldn't have two places where we need to have these queries, either at the codegen level or via intrinsics or at the IL level.
I don't think that you can say that they're necessarily orthogonal if you're going to allow, so consider, for example...
I don't mean that everything should be this kind of unobjectionable code that I...
Yes, no, I understand.
Like your compare and swap is side effecting, for example, and absolutely should not be one of these regular arithmetic-looking things.
Yeah,
but compare and swap cannot really meaningfully be optimized by the optimizer in any case. There's very severe limitations on what you may be able to do with it. Array copy is another example. It's so heavy, you've gained most of the benefit of making it an opcode by generating highly optimized code for it. That's 99% of the battle. waiting for the opportunity to hoist an invariant array copy out of the loop unlikely to appear. So it depends on your intrinsic in question, I think. The likelihood of being optimized, the likelihood of it paying off, those things should play into the pop count example maybe isn't so, and the gains from special casing it as a call and generating some specialized sequence for it don't make it worth it on its own. Maybe you should make it an opcode. Maybe the gains can only be realized if it was allowed to be hoisted and commented and so on. That inherently it's not enough to just generate an optimized sequence for it. So it's different cases, different decisions, but those are some of the factors that should play into it.
I'm sympathetic to Philip's concern too about the combinatorial explosion of opcodes, because we combine them with the particular types, and if you want to have 50 intrinsic type sort of operations times n types, you get this sort of ridiculous situation.
So isn't that easier with an intrinsic, because calls of every type already exist, and you don't necessarily need a symbol for every return type, right? So in that respect, choosing an intrinsic is a lot easier than having to come up with every variation.
There are other drawbacks to a call, right? If you are going to take the call and you're going to start trying to recognize that call, that is much more computationally intensive than checking the enum value for a given node is a certain thing, right? It requires inspecting the symbol on the call, the SIMREF on the symbol on the call. You have to query properties about it, figure out if it really is the thing that you're looking for, and that ends up being computationally expensive if you're going to do it everywhere. And the code, even if we introduce better APIs to do it, is still going to end up looking like a spaghetti factory if you end up having those sort of wired throughout the optimizer, which is not really a situation I really want to see.
Okay, so I've got two ideas for sort of like in-betweens for some of the cases. I don't know if I'll just sort of float them and see. Maybe people hate them or what.
Or in-betweens between?
Between opcode and intrinsic, and between requiring support and querying support. So the first one is maybe we can have some kind of like here's an I think Leo was saying something similar. We could have a sort of arithmetic-like intrinsic opcode with variance. What that does is it could be allowed to look like normal stuff, right? In that it floats around, it's referentially transparent, you can do remat, you can hoist out of loops and all, whatever you want to, those sorts of things. But it would keep the combinatorial explosion out of the opcode list. For the sort of sub-operation variance, you could get rid of the combinatorial explosion in there by having like this operation with a separate type stored or something. It would be less intensive to find what the operation is than one of these intrinsic calls, but more than a regular opcode. So there's a sort of idea.
How do you identify what the operation is that this opcode is supposed to be doing? Symbol reference, or is there a enum, or
like some sub-opcode enum or something?
So we would define a so we would define some enum somewhere of a list of known operations that could be represented by this kind of node.
Right, like
People can
extended
come and
arithmetic
add.
operations or something.
So it's its own opcode family. Some other type of opcode which will have types associated with it. Let's call it intrinsic call or something. It'll have type versions of intrinsic call. An intrinsic call will not have all the baggage that a normal call has.
Yeah, something like that.
In particular, you're thinking intrinsic call will be a treetop or not?
Not.
But it is a call at its core.
Well, I think you're also calling it intrinsic
It's
call.
supposed
call
to
it
not be a
intrinsic.
call, right? Ideally,
No, from a
you know,
codegen perspective, a call instruction has to be generated. Is that right or no?
no, because so what you want popcount for example, is that on, you know, architecture A, there is a popcount instruction, and you just generate the instruction and you're done, right? Like that's what it's there for. In the good cases, it's like one instruction or something. In the bad cases, it is hopefully not very many instructions. At worst, you can generate a call instruction if you need to, but I think it would have to be done in such a way that like it's guaranteed to have enough stack or something so that it's not an exception point and that sort of thing.
Then you get into the same situation that a call can appear at an arbitrary point in the IL, which the cogen may not be prepared to do.
It can have any linkage that's helpful for the cogen, right?
It's the cogen's decision whether to generate a call. You can't.
Be forced to handle those instructions. The cogen cannot treat them as transparent call. If I understand your proposal correctly, like.
Okay, so there's the second idea.
Yeah.
So the second idea is some operations that we don't want to require cogen to support, we could instead define a lowering so that it's not like we avoid generating it. We'll just wait until we're about to cogen and then lower the ones that the cogen doesn't like so that it doesn't have to deal with them.
Lower it into what exactly?
It would depend on the particular operation.
So for a pop count, what would it be?
Count the numbers, right? Like generate actual instructions in a loop or whatever.
It would be
Yeah.
IL level or?
Yeah, it would have to be
Yeah,
IL level.
That would be.
Yeah,
It would
and
generate a
at the
whole
very
block?
worst, you could generate a call to a.
Right, but if it's not anchored, then you have the danger that this is a child that's evaluated as part of the internal control flow sequence
Right.
for a check pass or instance of or something like that. And as soon as you have that, then
No,
you're
but
snookered.
so for what the lowering would do is if it had to generate a call, it would be like a regular kind of call getting generated. That would get anchored before, right?
That's just similar to the rebar stuff, the rebar. That proposal, I can see the similarities between that proposal and the rebar stuff. Like we don't generate a rebar until the right before cogen. We recognize some A load or I load, and they convert it to a rebar
So
call.
that's a temporary state of affairs.
Yeah.
So that is not a permanent design decision. That was a compromise for engineering purposes.
I see.
Ultimately, they should be generated in ILGen and persist for all time. It's just that we needed them for the POSLA's GC work, or there was, OpenJ9 needed them for POSLA's GC work to record side effects, and we have other uses for them. And teaching the optimizer about that opcode is a non-trivial undertaking. And if you put it in early, you have, because of the very specific semantics of how it's being used right now, you'd have a lot of loss of performance that you wouldn't otherwise need to have, but that's not the end state that opcode should end up in.
I see.
All right, so regardless of the comparison to the read barriers, I think there are benefits of this idea, which are that cogen doesn't have to be required to implement the operation directly, although it can, and it would generally be faster if it did. but you know, most of the rest of the compiler doesn't have to care whether CodeGen does that, right? It doesn't have to be like, oh, you know, do we have a pop count? Do we have a square root? Do we have one of these? And be careful about it. You wouldn't have to. It would be a non-issue on each side of the translation.
So the lowering phase, if I understood this correctly, would take an intrinsic call that may not have been the treetop, create a treetop out of it with an actual call opcode in that node.
Well, like at worst, right?
At
There may be
if
better
the
trees that we
doesn't
can
have
replace it
support
with.
for it. Yeah.
That's treating as if you had a pure call and the optimizer did the right thing with it.
Yeah.
And introducing it at lowering phase.
You can do it on opcode as well. If it was an opcode, IL op,
Right. You could also do that with opcodes.
right?
So
But with opcodes,
you can like one of these and not like the other, and vice versa, if you want.
Well, the disadvantage of doing it with opcodes is that you'll have an explosion of opcodes, right? For every operation, you could have.
Or you're just lowering it into
For that,
to something simpler that CodeGen could actually generate instructions. If I don't have a pop count, I would
Right. Or if I don't
generate
have a certain kind of rotate or something.
Yeah, I would generate a loop beforehand that loops through each of the bits and does a masking and calculates the result. And where the original pop count appeared, you refer to the final value or something.
But that would require you to implement the pop count in IL, whereas
That would require one person, right? It would be in the IL,
Right.
but
Which is
all the other codegens could take advantage.
Right,
Right,
I understand, but presumably,
That specific example isn't another way to implement the opcode in the IL to do a full-on call out to the method that you recognized in the
presumably you're recognizing a library method,
Right.
and you're reducing it to pop count. Why couldn't you just inline the method on the platforms that we don't support pop count, not generate it in the first place?
Right.
That's a good question.
And then you can probably optimize even more.
Are you recognizing the library call though?
Well, that's a Java or a dynamic language statement, like C,
Right.
for example. If we're actually using this for a C compiler, you're not going to be able to necessarily inline.
Right, but many of these
Why?
come with libraries which have quite generic operations on them, like pop count.
right. Well, the point of the
lowering
pop
is-
count operation there is to allow intrinsics to happen, right? That's why they put it there.
Right. One drawback of this approach is the size of the code growth that's going to happen when those unimplemented intrinsics exist, right? So if you're going to build a loop in IL for every pop count that you encounter, and that loop is actually going to look the same regardless of the pop count, the size of the code that you're going to generate can end up looking extremely obscene. Now,
Yeah, I wouldn't suggest that the lowering should do things like split blocks and insert loops.
but for some of these things, unless you're going to call a helper library, implementation is necessarily going to require some kind of control flow.
And the other thing about that is that
Do a helper library. Also, you can do pop count without looping.
but your performance, so for the platforms that don't want to support pop count, the performance of that code that you may insert may be worse than what you would have been had you introduced it earlier in the optimizer. Like, it doesn't get a chance to
Well,
participate.
Could have gotten optimized away.
I guess it depends on whether that pop count, for example, got hoisted out of a loop, which it, you know, sort of magically now is allowed to be, whereas you can't hoist your loop out of a loop if the implementation of that method when we inlined it would have been a loop, right?
But
So it all really depends on what happens.
I was thinking specifically about the implementation, let's say, of a pop count that has a loop in and of itself.
Right.
Right. The optimization of that loop may not be optimal. Like, you can't do global register assignment on it, for example.
Right.
After lower trees. So you may get less optimal code had you introduced it earlier in the optimizer. So. And the other, sorry, I have a
Right.
question about the inputs to this, though.
Mhm.
Are you assuming that you're going to be able to create a new opcode for every intrinsic that you want to do, like pop count or square root, or is that the input to this lower trees? Or
So those would either be opcodes if they wanted to be opcodes or these sub-opcodes of a sort of extended arithmetic opcode if people like that. Right, so you could do either of these or both or neither. Right.
We argue with that, yeah.
They're independent but related.
So I will say that I'm generally a big fan of lowering because we're actually doing the work anyway. It's just the only question is where. Are we doing it in every code generator? Like if popcount makes it all the way to the code generator and nobody has instructions to do it, everybody gets to write a popcount loop or something better if it exists in each code generator versus if you lower it once and an IL representation exists, it's only done once and not for everybody.
Right. And if the code generator can do better, then great, right? Then there's an opportunity.
So we're exploring a design point around this already for the profiling infrastructure, right? So JProfiling, the new profiling infrastructure, has value profiling as one of its features. And so to do that, you have to observe a value, and that value gets stored into a very carefully crafted in-memory hash table using various rules. Now, currently, for profiled compilations, we generate one of those guys for every single value you want to profile, and we generate those late in the optimization, but ahead of code generation so that there are optimization passes that take place, GRA can happen, and you get maximum performance, but you get a compile time penalty because of that. It has to participate like anything else. Now, there are cases where we want to do the value profiling, but we don't want to pay that cost, right? We don't want it to be maximum performance because it's going to be off 99% of the time. So the standard way that you would do this if you go to the code gen playbook is that you go and build an implementation in out-of-line code or snippets or whatever. You have an implementation for what that thing's going to do. You make it look like a call or whatever, and you put the right children on it, and hey, whoop-de-doo, you're going to jump off, do the thing, come back, and the register assigner will sort things out for you, right? Now, the problem with that then becomes that you have one implementation for code gen, right? And they all have to agree now with the IL implementation that exists for profile compiles. So we're exploring trying to common up the IL representation, and Ben's been doing that.
Yeah, I've been working right now on, where we're at is we're doing block splitting post-GRA. Yeah. We have not seen great performance out of that, but we're not 100% sure why yet.
Yeah, we haven't gotten to the end of the experiment.
Yeah.
We're trying to deduplicate the IL, in other words, and treat it kind of like an intrinsic sequence.
But in theory, it is possible to do lowering into loops after GRA, but difficult.
I think that the nature of the lowering will need to be constrained for the sanity of all concerned when it comes to the structure of the code and what's going on. I think that,
for the record, if we were already doing this kind of lowering and somebody wanted to put a loop, I would probably ask them to try to not do a loop.
Yeah, and I agree that there's going to certainly be a certain class of potential intrinsics that don't require lowering into a loop, right? We're going to lower it into a call or some other much more benign looking sequence that needs to be anchored at a defined point in the evaluation, but other than that, it's sort of like a straight line sequence.
Which pop counts can be done, by the way.
Whether, thank you, point taken. But regardless of whether it's pop count or sine or cos or hyperbolic tangent or hyperbolic arc tangent or whatever, it doesn't really, like, what we're talking about is whether we're going to have this facility and if it's generally useful enough and will provide enough utility for the complexity and mental complexity that it introduces to those having to understand and manipulate the IL versus going to the call route where, there's a bunch of things that aren't going to happen. Do we actually care? Right? Do you actually care? Is the fundamental question there. And is it worth all of this complexity and all of this engineering to do it.
Currently, we're doing similar things in the simplifier. For example, we in the simplifier we transform certain integer divide into the multiply, and then it generates a big IL sequence which won't be which can't be optimized, and if we have such a facility to lower a opcode, we can move the similar things from the simplifier to the lower trees.
Oh, I don't disagree. What I'm questioning is whether the engineering effort and the mental complexity and the amount of smacking heads into walls trying to make sure that this all works and stays working is worth the benefits that it's likely to reap for the set of operations that are likely to be representable by it. I agree that it is an interesting halfway design point, but I'm not 100% clear on whether the benefits that you're going to reap are going to be sufficient to warrant the complexity.
So I think the things around the opcodes are again, they're separate from the lowering idea, right? So you can have opcodes that are required to be implemented by every cogen, or you can have opcodes that that we try to avoid generating, or you can have opcodes that we generate and then lower when the cogen doesn't like them, or maybe other possibilities. I don't know. But it's not like if something is an intrinsic call that makes it work on cogen, right? Like your intrinsic call either has to be handled by cogen, or we have to know not to generate it, or we have to lower it, or we have to do something, right? Mm-hmm. So that's not a matter of intrinsic versus opcode.
So why do we want to minimize the number of opcodes? For example, for the popcount case, the cogen or simplifier even VP have to know the type for each time we need and do something with it. So for example, in the cogen, we have to differentiate whether it's in ipopcount or lpopcount. And having the two entries in the IL opcode enum doesn't make things worse. Or having to consolidate that into one entry inside the intrinsic cost, it won't make it better. We still have to figure out the type every time we need it.
Sure. I guess my argument in the issue was based on my presumption that IL should be supported on every platform that exists in IL form. And if you want an intrinsic, which a platform doesn't support via a single instruction that comes from a particular call reduction at the library level, then that should be a cogent query, whether we should opt in or opt out. So popcount is a perfect example of something today that's typically implemented in a language library and something that you would reduce to either an intrinsic or an IL. On Z in particular, we don't have a popcount instruction yet. So that means for us it's much better to inline that library call and let the optimizer do its job on it rather than transforming into an IL that we don't support and doing something weird.
Right. So I guess your point is every single platform should support all the IL.
I'm of that opinion, yes, because it makes implementing the IL on another architecture, for example, ARM, quite a lot simpler. You have a defined set of IL which you have to support. You implement that IL and everything just works. Rather than ARM potentially not supporting, a 64-bit load and them adding a 64-bit query. Do I support L load? Yes or no?
Well, I think it makes sense that everybody should support L load.
Right, I agree.
But regardless of the representation, if we have some explicit representation, we just have to know for every operation whether it's required to be implemented or not, right? So Now, I mean, I guess if you make those things not opcodes, then when something is an opcode, it makes it obvious. But the set of operations that you are forced to implement are exactly the same.
Right.
Right.
Another thing is like we cannot force every platform to implement things like a compare and swap for synchronization. But we chose to.
Which is exactly why it's an intrinsic.
If we require every platform to support all the ILs, so I think the compare and swap should fit in the IL category because we cannot force every platform to support a compare and swap. We use that, like, we rely on compare swap for all the synchronizations. And
So are you saying it should be an IL or not?
well, if an IL is defined to be like required for every platform to support it, then compare swap should be the IL.
Sorry, the converse may not be true, right? All IL is required support, but not all intrinsic, even if it's supported, should be an IL.
Okay, so you're saying like for certain intrinsics, we also require every platform to support it.
No, that may not be the case, but it could be.
Okay, I see.
So you want to be able to generate IL without having to check if a particular code generator supports it. You just want those to be
right.
Without any constraint whatsoever. You can always generate them, and if they will always work.
Yeah.
Whereas intrinsics have to be something that is queried,
right.
or that's a line that you want.
Right. You would query codegen whether you support a particular intrinsic.
The other line that we discussed 15 minutes ago was if something behaves like a quote unquote simple arithmetic operation and it can benefit from being optimized without the optimizer actually knowing what it is. That's another line, and those two lines are not. Like, how do we have to come up with a line, right? Where do those? What is the intersection of those two
right.
lines?
Well, so one area where an intrinsic can be significantly simpler to implement is if a particular language, particular implementation wants to have its own intrinsic of some kind. Adding an opcode requires a change in OMR, which impacts every downstream consumer because the opcode enum table changes. There's a bunch of things in OMR that need default implementations, yada, 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 yada. If you have a call, right, like if you have a call, the call is a call is a call. Now, the particular semantics you attach to the symbol and symref that you attach to it, you can deal with in your language code gen. The symbol that you generate can be isolated into your derivation of the symref tab and the symbols underneath it. And you can then get the customized behavior without requiring an OMR level discussion on the utility of the particular feature you wish to implement and the imposition of that feature on the entire universe of OMR languages. So that is, like, I think one of the unique things about that.
So you're advocating an invoke dynamic for...
No, I'm not advocating invoke dynamic. What I'm saying is that the current pattern that we have for non-helper intrinsics is a pattern that that more easily allows language-specific extensions for particular corner case opcode requirements. Whereas if you had to add them to the opcode table and extend everything, you have a huge amount of stuff that suddenly has to care about it, right? The evaluators, the optimizer, the IL tables, the debug infrastructure, the blah, 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 like the list is a page long. Anybody who's added an opcode soon runs into that, that sequence, right? So,
and because it came up in the discussion, this is basically what the LLVM guidelines boil down to in their documentation is intrinsics are a much simpler extension mechanism for them than introducing a new instruction. So if a project sees the need to have to describe to the compiler some behavior for which there's no existing intrinsic or instruction, they can start by defining their own intrinsics, which is fairly straightforward in LLVM, and then later on, if the community decides that there is enough value that it warrants its own instruction, that can happen later on. And if not, the project can still just keep the intrinsic around.
Right, and there's a set of conservative assumptions that apply around those intrinsics. They participate in optimization in certain limited ways, but that's it.
If we had a well-behaved extended arithmetic or intrinsic opcode, supposing that the flags can be assigned in a sufficient way for all of the sorts of uses under there that you might want, the sub-operations inside that could be made extensible so that a downstream project could add its own?
Yeah, I think there certainly is value in the notion of the intrinsic opcode. I think the question that needs to be answered, the question on whether it is worth introducing that into the IL comes down to how many of the intrinsic type operations that we are considering as potential intrinsics reasonably would fall within the loosened set of constraints applied to the intrinsic opcode versus a call.
Right.
And is the benefit provided by their participation in that larger set of optimization warranted for the mental complexity that we have to explain? Okay, well, there are two ways that you can put in custom semantics. One is as a call to a non-helper or whatever the hell we're going to call it, right? And that is like a call, and it has all of these restrictions, but it will get through the optimizer in these certain ways. And we have this intrinsic thing that the optimizer can do more things to, and it can participate in other ways, and you can encode a set of semantics with that, and those are our extension mechanisms. Or you kind of just go with the call and you pay the performance penalty for the simplicity.
So since we just mentioned LLVM, let me interject there and ask, obviously they have a notion of a call, and they have a notion of an opcode. Do they have a third notion? Is an intrinsic call, an extended arithmetic, or whatever you want to call it?
They do have the notion of an intrinsic call.
Okay.
So they separate out their intrinsic, the intrinsic call and the regular calls are separated.
I'm not an expert in LLVM, but yes, I believe that's how it works. And then they also have mechanisms for extending particular optimizations, such as code constant folding, so that you can teach it to handle your particular kind of intrinsic, if that makes sense.
I believe in LLVM, all the instructions are supported in all the platforms LLVM supports as well. Instructions being our version of IL.
Yeah, I believe that they are supported on all of the platforms. I do believe that there are some cases where people have implemented things as calls rather than as intrinsic calls because of the set of restrictions imposed on calls versus intrinsic calls in the optimizer. It's this trade-off of freedom to move and optimize versus correctness depending on the semantics that you're trying to encode.
Right. And on that, and sort of in addition to your Andrew's point about how many of these fall into the category where they can sort of allow nice things to automatically happen to them even though they're opaque. What I would like to add is that the ones where we can't automatically do nice things, even though they're opaque, you're not going to get much benefit out of making them anything but a call, right?
Yep.
You might as well just make it a call. It's fine.
Yep.
So it's sort of like I guess that idea is really restricted to those types of things.
Yeah. And I guess the follow-on to that I would say is, well, if we're considering arithmetic type extensions, right, things that come to my mind are things like square root, sine, cos, you know, some of these things that we don't represent explicitly in the IL at the moment. A lot of those are floating point operations of one kind or another. The semantics around floating point operations is inherently already a thorny topic in our IL. So if we were to allow an intrinsic, like a floating point returning typed intrinsic, that inherently feels like something that's going to be very difficult to have the right behavior in terms of precision and those other things sort of in general. And so is it that those things would have to be calls because of needing to preserve the precision and evaluation order and rounding and whatever else? And if so, does that only leave us with like a subset of integer things that would be useful? It's just one thing that I would toss out there for consideration.
So you can't do any reassociation or anything like that without having some knowledge of what the operation is, right? So, you know, it's not as though if we say, oh yeah, now sine gets to be a node that floats around, that somebody's going to come and you know, just change its arguments because it knows that, you know, whatever, things don't apply these properties to sine right now, or if they do, they only do it in cases where it's allowed. So I don't think you're sort of opening the floodgates by doing that. I think the thing that is most troublesome there, right? So there are issues about the widths of floating point numbers, but in almost all cases we just have 64-bit IEEE all the time. The things aren't getting shuffled around in any way. The only thing that I would be wary of is if it's possible for us to change the rounding mode. Then, you know, if you move the computation or if you comment it or something, there may have been a rounding mode change in between. Which is, I find it really unfortunate that the hardware works in terms of mutable state with respect to that, but that's what we have.
I think that if we are comfortable, like I was throwing it out there just as one of those points for consideration. If the feeling is that, well, the things that are going to happen to the floating points will happen to the floating points, you opted into it, bonne chance. I'm fine with that. I guess it's just the question on the general utility of that mechanism. If we think enough stuff falls into the bucket, the answer may well be yes. I'm just, there's an engineering overhead that we have to pay and a cognitive overhead, so to make sure that we're cognizant of that in choosing to have the middle of the road.
Off the top of my head, I think there's some, from the perspective of OMR, in terms of language support, I don't know how much of a performance hit or benefit for the Congress case there would be to either allowing or disallowing these kinds of floating point operations. I do know that, of course, different languages are going to have different requirements. I know Java has very strict requirements when it comes to rounding mode and floating point related operations. At the same time, a language like Lua has practically no restrictions, and things can kind of get rounded however, and it's kind of up to the application to make sure.
Wild west of floating points.
If it's loosey-goosey enough, then the compiler can do it at once.
So I guess from that perspective, it's, at least with my relatively naive understanding of the optimizer, it's kind of up to the language implementer to decide to use intrinsics or a call as appropriate for the language they're implementing the JIT for.
Oh, I completely agree. I guess all I'm positing is how many times is the language designer going to opt into the middle of the road path to warrant the complexity that it's going to require?
Fair enough.
I need sign. I need sign. I need sign.
I need sign, but I want it as a call. I need sign, but I'm going to make it an intrinsic. I'm going to have both and use them at different points because it's cool. When it's a sign, not a sign. When it's a call.
I would like to believe that if someone wants to do that, they're just asking for trouble and you can just ignore them, but I don't have at the moment.
Yeah, I mean, I certainly can see utility if there's enough things that participate in this looser way of restricting the motion and the commenting and the whatever. There's certainly value there.
What about for vector instruction, like vector operations? So if we require like each platform to support all the ILs, the vector operations should not be part of the IL. So we can't require all the platforms to support all those.
Those are already
certain array translates, and like we've got some stuff in there that's not exactly.
Well, and the vector opcodes are kind of weird because the stride is not encoded in the opcode, which. Right, so.
There's actually a new proposal that hasn't been written up yet. Nikita was going to write on
a couple thousand opcodes.
This little opcode of mine, I'm going to let it shine.
Yeah, but you're definitely right there. Vectors would require certain architecture levels.
Right.
Or just off the top of my head, I can think of.
They're not things that should be calls, though.
No, fair enough.
We should make them calls and anchor them on.
Yeah.
I mean, the way that ARM had implemented floating, like there is soft floating point in ARM, right? The way to implement that is by turning all of those operations into calls, right? So I have to do A and B, I'll call fadd. I'll call an fadd emulate kind of thing, right? So it is able to get away with implementing calls for all those floating point operations.
Oh, right, but where you do have vector support, right, turning your simple vector expression into call is probably not the best way to optimize it. And
just what I was going to say is, and specifically in the case of ARM, it's kind of an interesting data point because in ARM 32, vector instructions are optional under certain variants of the architecture, meaning that they can be available on some processors but not others.
Like goes for like all the SSE extensions on Intel, right?
But I think vector is kind of a special case because typically they're not modeled by something in a language.
Right. So it's something that, I guess the question is, would you get them straight out of ILGen?
Typically not.
Right. It's something that you would.
Not at the moment.
Right.
Not at the moment.
WebAssembly could totally do that. It does have.
Yeah, well, and there are discussions underway in the Java community about adding libraries that map.
I think that's the exception rather than the rule. Most languages do not have built-in vector support at the language level.
Yeah.
I think when we talk about architecture support, we're talking about typically things you would map from a language syntax.
I think vector is one that we should just sort of leave in its own special box. There are vector registers. There's special vector hardware. There's vector all kinds of stuff. Yeah. So that I think is kind of outside the scope of this discussion. I think this discussion is I think we should just put that in a box, leave it in the corner for another day, because that's a whole different problem.
So what do we think are the next steps here? Is it if one possible proposal is to go with some kind of a limited intrinsic opcode, similar in intent and maybe scope as what is available in LLVM. I guess we can roll in the two proposals from Devin as well. And
I
then
think Devon's proposal is, at least one of them is very close to that.
One of them is that,
Yeah.
the other one is lowering, right?
well,
Yeah,
The
Yeah.
lowering, I'm
a little shaky on that as well.
yeah, I'm more shaky on that one. I mean,
Yeah.
if we have an extension mechanism in the IL for intrinsics, having a query on the code generator to say, is this intrinsic supported, right? You're not querying every opcode. There's I want to know if you support this intrinsic. Well, that feels to me like a morally justifiable thing to be asking, right? And either you generate it or you're going to leave it as a call.
Yep.
And it's going to be a call, and to hell with it, right?
so is there a volunteer here for someone to write up a proposal for an intrinsic opcode and what that would entail?
I thought there was talk of that middle of the road proposal, that not an opcode, not a full call. We weren't convinced that there were enough use cases to warrant that. Certainly our past suggests that we have use cases like that, or we didn't think the burning need to go that route. We don't have an intrinsic call opcode today. Proof of that. We could have been wrong in some cases. We should probably look at all the cases that we do intrinsic calls in the original form for today. Look at that set, see if some of those would be candidates for this middle of the road proposal. If we can find some, then perhaps go down the route of drafting up a proposal along those lines. I'm still not convinced that the middle of the road is actually worth it. I think if you're either here or you're there, that's served us fine for so long, I need some more convincing before start designing for it.
I will add to that point. I do agree that we should look into how this would be useful given our history. I will point out that because historically this was developed, or the compiler technology was developed in the context of Java, there may have been less of a need than there is now, because now part of what we have to consider is how other languages might want to extend opcodes.
Yeah, there's never been a language agnostic intrinsic even thought of as far as I know.
But before going through all the machinations and hand wringing and head slapping that's involved in actually doing the full design for this thing, perhaps someone from one of the teams that has more exposure to things that aren't Java may be able to sketch a set of use cases for the intrinsic, either opcodes that we currently think should turn into intrinsics because they're never used, or here's a set of things we currently make calls, and gosh, would it ever be nice if, and then here's all the other pie in the sky things that would be kind of cool to do. And if that set looks sufficiently big and attractive, then it may be worth the effort to do the design.
Frankly, the best argument I've heard so far for an intrinsic, some other intrinsic call type opcode is that LVM does. At the moment, I don't know of a better argument that's been expressed in this meeting, a concrete one at any rate.
And perhaps the use cases for intrinsics in LLVM may provide the inspiration for whether we wish to go down that road.
Yeah, that's a very valid point. Like, we could look up why they thought they needed that, also look up what we have in our past and see if anything qualifies, and then have a better discussion of that.
Yeah. There's certainly pluses to it, and it should be considered, but I think the utility should be considered as well before the complexity is added.
So maybe one more item to consider, just kind of building off of what you just said, is also look into, since one of the features that LLVM supports is this ability to teach certain optimizations to handle intrinsics, what that would mean in our case. Would it be possible to also have ways in our ecosystem to have languages be able to extend certain optimizations to teach them how to handle particular intrinsics?
Yeah, if we thought that was a valuable notion in our IL, I think we should invest in teaching all the optimizations about that, make it a first-class citizen.
Right. Well, I think that's in the LLVM guidelines, that is one of the things they specify, is that if someone has found something that they think warrants creating a new instruction for it, they start out by implementing it as an intrinsic. That way the community has time to look at it, think about it, figure out how it's going to play with the other optimization. And after some time has passed, it can get promoted to a full instruction.
I mean, the fact that it would be its own opcode, there's already kind of a built-in extension point in most optimizations because most optimizations work on the opcode, and providing a hook or some other means of intercepting that and doing your language-specific thing and delegating or not as you feel is going to be fairly natural from that perspective for a lot of things because opcode.
Yeah.
But I think.
Okay. So why don't we move on to a more concrete thing in terms of it that Nigel was inquiring about. So the popcount opcode, want to keep it? Intrinsic? What do you want? Or a helper? What do you want to do? Did we get any closer to making a decision on that?
I personally think we have to finish this other discussion before.
Or does it wait?
I think until we know the universe of possibilities for its fate, I think it's a bit premature to assign its fate.
How is it handled currently?
It is not implemented on C.
Is there a query on the code gen saying, do you implement it before generating?
I don't think there is even, there may be a query asking,
There is a query
asking
otherwise
I forget, some
generate one.
high-level front-end class, do I support generating this IL? And it's a specific query for popcount, not general IL.
I believe for each individual like opcode, we can query the code and see whether it supports opcode.
I don't think that's
I'm not aware of that.
it's not a consistent kind of API. It's more
No, there was something shimmed in for popcount on x86 for a particular purpose at one point in time.
If you ask that cogent query about a load, an I load, I'm not sure what it would say.
It was introduced as the original introduction of that opcode was done as part of the profiler implementation on x86, the JProfiling implementation on x86. That's when the opcode got introduced because there was a use for it.
Okay, all right, so that one will...
There's no unified query on all the cogens and platforms which ask whether I support a particular IL.
No.
Although,
in general.
You take a look at the intersection or some cross-section of the evaluators implemented, there's no such query.
I would mention about the use case for it, that at least in Java, there may be users calling this with the expectation that they're supposed to get the instruction they want on the processor they're running on, and they're not getting it if we don't do that.
Okay, so why don't we just move on to the last one then, Victor, proposing renaming NonHelpers to something else.
Yeah. Because the name of NonHelper is quite confusing when I'm working on it. Well, it is a call. It is a call to a helper, but it's named as a non-helper just because we normally don't generate a call instruction to the helper.
I guess we can make this one simple. Does anyone have objections to renaming this?
Well, I think before it gets renamed, I think we need to decide if we're adding an intrinsic opcode, because I sure as hell don't want an intrinsic opcode and an intrinsic symbol.
Exactly.
Yeah, I agree.
So,
or we can rename it to something else.
Well, intrinsic opcode could be called something else.
yeah, I think we need to decide if we're doing the middle of the road thing, and then if we are, that dictates one set of design choices around names and other things.
Right.
And if we aren't, then it provides a certain other freedom for changing the names.
I guess we agree that non-helper is not a good name.
I do.
I think I do as well.
Obviously, yes.
Yeah, I agree. It's not intuitive.
Right.
So it's slated for renaming to something pending on other designs.
Right.
I guess it's the concern.
Depending on other designs and the appropriate time to minimize the disruption to the various projects consuming OMR. Because that rename is going to touch everything for everybody.
So then, just as one item to add to the things to consider for a possible notion of intrinsic or extended arithmetic or whatever it's going to be called is, when some decision is made about this, what will be the fate of non-helper calls?
Well, I think we're still going to want those kinds of things because certainly not everything is going to fit into the mold where you can float it around and do all of the transparent stuff.
Yeah.
Right? It would just be, what are they called? Yeah. We could, if we wanted to, hand the name intrinsic to those right now and force the other one, if we choose to do it, to have a different name.
Right.
But
yeah, I think I would rather arrive at where we wish to go and then try to create a set of names that is non-brain borking for all concerned.
Understandable. Yep. Yeah.
So I agree it's not intuitive. However, it's been that way since OMR was created.
Yep.
A few more weeks of being that way is not going to kill anybody. So I would much prefer that we arrive at what the happy future should be, and then we will slowly try to cause the world to move in that direction.
Yep. Agreed.
Tell you something that we should rename. That's non-brain borking.
I don't know, in BB, it's a good TLA.
treetop, but
Did not go there.
I'm not serious in this meeting right now, but it's not a good name.
Really, you really don't like it. I feel the same way.
Any other topics to discuss? No? Okay. All right. Thanks, everyone. We'll adjourn right now.